Alright, number 1. So when we derive the function, I guess I'll go f prime. Okay, ready? Rules. Multiply. So 16. Go down an exponent. Multiply front and top, so -5. And when you go down, it's nothing there. Okay, and then every time you derive just a number, it's 0. Okay, number 2, I'm going to rewrite this before I start. So -2x to the, what do you want to put up here? 1/4, 1/4. Okay, so now times, Ethan, what's your mental math on this guy? -1/2. Okay, and if we go down, if you want to know the trick, I would go down like a 4/4. That's what I'm thinking. So -3/4. Okay, that's going down 1, right? Okay, what are we going to do on number 3? You have rules now. So this is the product rule. Okay, so that's the idea. Okay, ready? Deriving the first. So that's a nothing. So this is -3x to the -4 times the original second plus the original first, and then derive the second unit. Okay, good. Just leave it. Don't simplify it. Okay, number 4. So now we're going to do the quotient. So f prime g minus f. You don't need to write this, but that's kind of my general idea. Okay, here we go. Derive the top. So 12x cubed, 15x squared, times keep the bottom. Derive top, keep bottom. Good? Minus keep the top, derive the bottom. So 8x cubed, all of it divided by the bottom squared. Okay, number 5, now we have the power chain rule. Okay, so front times the top is 5 of those to the 4th. 5 of those to the 4th. Good. Times the derivative of that stuff. So what's the derivative of the bracket? 3x squared, and I think that's it, right? Okay, number 6, I'm just going to think about that differently before I try this. So what's the original exponent on that? Did you pick a half? Square root is a half. Okay, derive. Ready? Front times top. So that's just a half of those to the one lower. and then attach the derivative of the bracket. So negative 4x. Okay, number 7, you're going to have to do 2 things. So I'm going to go this and this with the product. And then I notice when I do derive this, I'm going to have to do the chain rule on that. Okay, so here we go. Derive the first, so 9x squared times the original second. Good? Plus the original first. And then, now this is going to get tricky, right? We've got to derive that. So now we're going to have to do a chain rule on that. So here we go. 4 of those cubed times the derivative of the bracket, so negative 8x. Okay? Do you follow that? That's all G prime. This is the F, and that's the G prime. Okay, number 8. Okay, so we were asked to do a quotient rule. So, and we're doing this at an x value of 2. So I don't know if you want to plug it in now or at the end. We can plug it in now. So the quotient rule is f prime times normal g. Oops, I said I was going to plug it in here. So the prime, f prime times normal g, subtract normal f times g prime all over normal g squared. Okay, so that's the rule. Now you have to follow everything on the chart here. Okay, ready? F prime of 2, f prime 2 is this spot, so negative 1. Normal g at 2. You know what I'm going to do here? I'm just going to circle this all. These are all the numbers here. Normal g is 3. Subtract. Normal f is 4. G prime is 1.5. All over normal g squared. Okay, so what does that top all come out to be there? Negative 3 4 times 1.5, so that's negative 3 minus 6. So you get negative 9 over 9, which is a final answer of actually negative 1. Okay, this rule, so this will be f prime of g of x, then you have to attach g prime after. So that's that rule. Okay, so what is, we have to start here. What is the g of 6? The g of 6, did you pick 4 there? The g of 6 is 4. Okay, so I did that first, and then that was 4, so now I need the f prime at 4. F prime at 4, did you find it? Negative 1. And then g prime at 6. Are we good with my numbers? and then, so my final answer is 2. Okay, number 10. Now we're into trigs. So what's the derivative of the sine? So that's cos. Then you have to attach the derivative of that. So 6x squared. Okay, number 11, just be careful with understanding what the squared is on. So the squared is on this unit. It's not this is different, right? It's not that. It's not that, okay? The squared is just on that. Okay, so when we do the derivative, what's the derivative of a cos function? Negative sign. Okay, what's the derivative of that? What are you going to do when you derive it? You're going to have to do a whole chain thing, right? A power chain. So the derivative is 2 of those to the 1, or you don't need to write it, times the derivative, so negative 6x. So that is kind of like the u prime part of it, right? Okay. Number 12. So ln, this is the rule with ln. You derive and then you write the derivative over the original. So this would be 3x squared over the original x cubed. Okay, e, the rule is to do e to the u and then attach the derivative. So you just repeat it exactly how it is. I think that's a cubed, isn't it? My eyes. 2x cubed. Is that what you guys are seeing on your paper? Times 6x squared. Okay, number 14 is that implicit because looking at it, I got my x's and my y's all mixed up, right? Okay, so I'm going to derive. So this is 8x. The derivative of this, 6y squared. But what happens as soon as you derive a y? You attach a y prime. As soon as you've derived a y. Plus, so that derivative is 4. Oh, but I derived a y. So I have to attach a y prime. Okay, at this point, I'm looking all y prime stuff on one side. So it's already actually there. So once I GCF a y prime out, and then we can divide it out. Okay? Oh, good. I was going to say I'm going to have a little bit of a harder one on the test, but I see it on the next page. Okay, number 15. Okay, deriving each one separately, so here we go. So this is 15x squared. Okay, when I derive the next, I'm going to do a product. Okay, you ready? Deriving x is just 1 times the original y squared. Derived the first, kept the second, plus keep the x, derive the y stuff, becomes 2y, but then as soon as you derive a y, you attach a y prime. We're following? This was f, this was f prime, this was g, this is f, this is g prime. That's good? You're following that? Okay, on the other side, I'm going to do the same idea here. Okay, ready? Derive the x, so 15x squared, keep the y stuff. Plus, keep the x stuff, derive the y stuff. Oh, as soon as I derive a y, attach. Okay, now I'm looking at all the things that have a y prime in them. So this and this, right? So those need to go on the same side of each other. So I'm going to go 15x squared plus y squared minus 15x squared y cubed. So I moved that. Okay, are you okay with me making this number 15? Because there was a 5 in there and a 3 in there. So this is going to go 15x cubed y squared y prime. Subtract, because I'm going to move this, 2xy y prime. Okay, you're okay? I just like rewrote it. I don't like my 2 in the middle. I like my 2 in the front. Not a big deal. Those are the same thing. You're okay with that looking? Okay, now technically I guess I should factor this out. Right? So what is your final answer? You're going to have that division. Okay, so make sure every time you've done a derivative with a y, y prime. Okay, that's the number one thing to think about when you're doing that. Okay, number 16. I probably should have made a harder question on this type, but I didn't. Okay, write the equation of the tangent line and normal line. Okay, so I'm going to derive this. So 3x squared minus 6x is the derivative. So now I'm going to go, what is the slope at the x value 3? That's what I'm kind of trying to figure out, right? So 3 times 3 squared minus 6 times 3. So I'm going to get the slope. So that was 9. What is the perpendicular slope, by the way? If I wanted the perpendicular slope of that slope. You remember how to do it? Reciprocate, negate, flip it. Okay, so the tangent line will be 9x minus 3, 1, y minus 2. Right, I plug this coordinate in. And I think I don't know, I think I might give you that formula if you need it. And then the normal is the perpendicular. So we just change that slope to the negative 1 over 9. Okay. This was an easy question, so on your test, I would make it probably harder by saying, write the equation when it's parallel to y equals 9x minus 7 or something like that, right? I could add, and then you have to figure out, oh, at the x value 3, and then figure out the point, and then figure out the line. Okay? So that's more along the line of the test question I would put.